You often see pictures of polar bears looking like this. They're lying on the ice or lying on rocks and sort of spread out. And they look very relaxed and chilled, but they're actually doing something which is important to actually save their lives. Their fur is so good that even in the coldest extremes, polar bears can actually overheat. The insulation is that good. So they flatten themselves out on the ice to make sure they don't overheat. A polar bear is an animal that can be both cold and overheating and sweating all at the same time. That's exactly like a DBA or a developer the moment after they've done something catastrophic to their database, like drop a table or delete some data. You're both cold and sweating at the same time, which leads us nicely into flashback table. Some of the flashback technologies. You drop a table, you can use flashback drop to get it back. You manipulate a little bit of data in a table by mistake, you can use flashback transaction to get that data back. But what if you're somewhere in between, where you've taken a whole table and just munted it? You've just made a total mess of it. The most common examples are you've done an update or delete and you've forgotten the where clause, or the where clause is always true or something. And so the vast majority of all the rows in that table have been destroyed. You don't want to have to run flashback transaction for every single row, etc. Flashback table lets us get access to that kind of functionality. And the syntax is fairly simple. We simply do flashback table to a particular timestamp. Now, what's actually going on behind the scenes here? It's not the same as an undrop. If I've dropped the table at 9 a.m., I can't say flashback my table to 8 a.m. That doesn't work. I have to use flashback table to before drop, a different technology for that. Flashback table is simply saying I want to roll all the data changes back to a point in time. As I've mentioned in other places, you cannot untruncate. This is simply rolling back data changes. When I do flashback table department to a particular timestamp, what am I actually doing? I will say, let's look at the table as it was, say 20 minutes ago, if that's the nominated time. I'll delete all the rows that were modified in those last 20 minutes, whether they were inserted, updated, etc. And I'll delete all the new rows. So what happens is, effectively, I'm wiping out everything that's happened to that table in the last 20 minutes and then reinserting new rows for as they were 20 minutes ago. So it's a busy operation. So you can think of it as poor man's merge. We're not doing inserts, updates, and deletes. We're simply saying, let's wipe out everything that's I've seen since the nominated time and put it back in as it was. So it's a busy operation. Because it is just doing row stuff, it is deleting rows and inserting rows. If you have triggers on that table, you can nominate to have those triggers fire as well. So you might have, for example, materialized view log kind of triggers, or you might have audit triggers to actually catch the fact that someone's doing a flashback table. So you can have the triggers fire if you want. By default, they won't. Because we are deleting rows and reinserting them, the row IDs will change. So that table must be alter table enable row movement. And if for some reason you're storing row IDs, then be aware that those row IDs will all change. If you've got indexes on those tables, as I said, this is just a change to data. If I take a table back an hour, but I created an index just 5 minutes ago, that index is still there. We're just rolling back the data an hour. It is a single transaction, but you can do multiple tables. If I've screwed up the employee table and the department table, I can flashback both of them in one line, flashback table emp and department to a nominated point in time. The reason that's important is RI has to be preserved. So your tables are locked while this goes on, which obviously makes sense. At the end of the operation, your referential integrity must still be valid. So if I've got 3 tables that are sort of linked by foreign keys, I'm probably going to have to flash back all 3 of them to a particular point in time, which obviously makes sense. These statistics are unchanged. So if the table has 1 million rows now, and when I flash it back 20 minutes, it's only got 10 rows, the optimizer stats will still reflect 1 million rows. So you might need to do a gather stats at the end of it. The way we implement this is you'll see a table appear called systemp FBT, system temporary flashback table. Because we've got our original employee table, we're going to copy it effectively to an old version of that employee table and use this systemp FBT to architect all the changes to come up with this table as it was in the past. Make sure you've got plenty of free space available, because depending on how far you're going back, you may, as an interim, have almost 2 copies of the data. Most DDL is going to be a flashback boundary. So what will happen is if you want to go back an hour, but you've done some DDL on that table in 30 minutes ago, you're going to be capped at that moment. You'd get this kind of error, unable to read data definition have changed. Each release gets better and better each time we do this. So for example, in the current releases of the database, even if you've added a column, you can still flash it back to a point in time. But as I said, it's just data. You'll take it back an hour, that new column will still be there. It just obviously will be empty because you added it within an hour's time.